Hi everyone, this is Joe. Welcome to the new episode of Streaming Caffeine. I even have this special t-shirt I'm happy to share with you. And today I'm so glad to invite my friend Ozan from Synnada and the co-founder and the CEO. So Ozzy, do you mind sharing a little bit about yourself and your company first?
Yes. Well, thank you for inviting me, first of all. I've been following both Timeplus and your podcasts, so I'm very happy to have this conversation with you. Let me briefly talk about Synnada. What we're trying to build at Synnada is what I like to call AI native data infrastructure. So, what do we mean by AI native? I guess that's the question, right? Like everybody seems to be using this word these days, but what does it really mean? Um, I think what AI, to me, I think there is no uniform consensus on this, by the way, as far as I know. But what I understand from AI native is there are certain things that you need to do when you need to embed AI into your application. What? For example, you need to sometimes update your models, retrain them, right? Because maybe the data is drifting or something is going on. Or you need to observe what your model is doing. Or you need to optimize your model so that it runs very effectively at inference time because you don't want to spend too much compute. Maybe you want to miniaturize your models. Maybe you want to fine tune them for certain things. So there are all these tasks that you need to think about when you're designing an AI driven data system. So, what the AI native data infrastructure does is to abstract these away from you so that when you actually think about and develop your application and you deploy it, the deployment environment takes care of certain things, like the ones that I mentioned. I think a good analogy is to cloud native. I think that's how the word is coming, from where the word is coming from. Before cloud native, we would be thinking about things like, do I need a load balancer? How does my deployment scale? Do I need to, set up an auto scaling group? Or we would think about things like, how do I fetch metrics from my application? So now in the cloud native world, you don't think about these things. If you have your containerized application, that's all you need, because once you deploy it to Kubernetes, Kubernetes takes care of all of these things for you, right? We don't need to think about them anymore. What the world needs right now is an environment that provides the same kind of comfort for AI applications. So if your infrastructure is able to provide you with this kind of functionality out of the box, then I call it AI native. This is my definition. Like somebody else's definition could be very different. Um, but I think that's where the word comes from, like cloud native, AI native. So Synnada wants to be the data infrastructure technology that actually gives you this AI native environment so that you can very quickly prototype your AI driven application idea, deploy it into this infrastructure, and then some of these things come for free for you. So that's what Synnada does.
Okay, nice. Yeah, yeah. I guess it's the beginning of everything, right? So this AI native, it's become not really optional, almost must have, right? So many of new
Yes.
company and new project in the larger company organizations. And I also we have a little bit of this discussion in the past, and I'm so curious to learn about how you build your company. Especially, you mentioned you are using Apache Arrow or ArrowFusion to be part of your foundation to build a very solid and new database. Can you share a little more about that?
Yeah, yeah. So we are betting actually quite heavily on the Arrow ecosystem and particularly the data fusion engine, Arrow Data Fusion. And how we came into, came across Arrow Data Fusions, that story is also interesting. So one of the things that you need to solve if you're going to be this AI native data infrastructure is how do you how do you actually solve the problem of this batch and streaming dichotomy, right? Today, the prevailing architecture in data systems is called the Lambda architecture. Just like Lambda has two legs, you have actually two data infrastructures, and you need to maintain them in parallel. So
Yeah,
one data infrastructure.
I know Lambda, but I don't know that you mentioned that two legs in Lambda. Yeah, that's a good way.
Yeah, that's I think where it comes from. Like why else would it be Lambda, right? So anyway, okay. So you need to maintain these like two data infrastructures, which is a burden on data teams, right? Like you need people that know how to operate this batch system very well. That's probably Spark or something like that. And now for like scoring or like fast path kind of workflows, you probably have something like Flink, right? And then you need people who know that technology very well. And then you actually need to integrate AI onto these systems in a sort of bolt-on fashion, because these are old technologies, old in the sense that they existed before this AI wave, right? Yep. Like when Spark first came out, let's think about how Spark came out. It was Matei Zaharia's thesis work, academic work, and it was like a better Hadoop, basically, right? It started with RDDs, and then it went through a bunch of these evolutions, and it's a great piece of technology. But when it first came out, like we didn't have this machine learning mindset. I mean, machine learning existed, but it wasn't like this much in the center frame of everything. So these systems were designed that way. Also, they were designed before the cloud native era, right? So before cloud native, portability, scalability, all of these things were tough, and Java was like our go-to solution. So all of these technologies were built on Java. So if you actually think about, like, these are just two examples of why I call these technologies old. Like, they're not bad. They were just designed for some other world, right? So today, what data teams are trying to do is to still use these technologies to build their AI-driven data applications. But when you go through the experience, and I'm sure you've gone through the experience in your career too, it is not an easy thing to do. You have this batch part, you have the streaming part, you have to somehow add ML into this. You use things like, when ML first came out, Spark said, hey, there's this ML lib thing that you can, work with. So it's always added on later. Mm-hmm. And this is fine, but at some point you start piling stuff on top of each other, and it becomes hard to operate. And that's where we are at right now, in my opinion, with respect to data infrastructure. So we have this ML stuff that adds on to the current technologies, and then you have this observability stuff that adds on to the current technologies, the ML ops, X ops, data ops, pipeline ops, whatever ops you want to call it. So all of these things are like bolted on, and even though like engineers are able to still create data systems that work on top of these, the experience is hard. Every new data application you build it takes a lot of effort when you're building them. It creates a talent gap. Like, not a lot of people know all of these technologies, and it's hard to hire people that are well versed in like most of these technologies. And then because all of these things are added on, it becomes a barrier. And how do you try to solve this barrier? You try to get yet another tool to make things easy, and the barrier is higher now. So it's like a vicious cycle, right? So this is like the problem that we were seeing with the data infrastructure today, and we were searching for a technology that had the chance to deconstruct all of this, right? Like, what are the fundamental ideas? If you can actually deconstruct all of this, then maybe you can end up with a system that's as powerful as this kind of big composite complex system, but it is much simpler, because now you have the chance to rethink everything, and you have seen all of this historical progress, and then you have deconstructed all the fundamental ideas, and you end up with a much simpler picture. So we found the ArrowDataFusion query engine as a result of this search, and it's not obvious, when you first see it, like why is it making everybody's lives simpler, right? What really clicked for me was a talk given by Andrew Land. I don't know if you talked to Andrew Lamb on this podcast already. Have you?
Not yet, but I should, right?
You should. You should. He's the PMC of Arrow, by the way, the Apache Arrow project. I'm sure he has a lot of interesting insights to share with you. But in one of his talks, what he said was, we want to transform the space of data systems like how LLVM transformed the space of programming languages. What does that mean? So this sounds a little cryptic at first, but if you know how LLVM works and how it actually helped people create new programming languages very easily, then you actually understand what he means. Before LLVM, people would be thinking about things like, what is the parser I'm gonna use? Is it gonna be like a LR parser, LL parser? What kind of parse technique? What is my intermediate representation gonna be? What is my compiler backend gonna be? You would think about all of these things, and it was very hard to create like domain specific languages or anything that has to do with a new language, right? Like inventing a new language was like very hard. But LLVM actually came into this space, and basically what LLVM offered was, look, I deconstructed all the fundamental steps in building a language, some of which I shared, and now I give you these components to do all of these, like front-end parsing, intermediate representation, back-end optimization. All of these things are actually like distinct steps that I can encapsulate in a modular way, and then you can pick and choose from these steps and very quickly design your own programming language, right? And it will compile for, Mac, it will compile for Intel, different platforms, different OSs, all of these like previously hard stuff. By deconstructing all the fundamental concepts, I will make it easy for you. So now that we know this context, I think we can understand what Andrew Lamb meant in his comment. What Andrew Lamb was saying is, look, we're going to deconstruct all the fundamental things in building a data system, which are things like, okay, how do you parse a SQL? Okay, that was something that people were thinking about before. How do you make a logical plan? What are the fundamental components in your logical plan? How do you do logical plan optimizations? How do you convert it into physical plan? How do you do physical plan optimizations? All of these things, we are going to deconstruct them for you, and we are going to give interfaces to all of these things. And now, with interfaces at your disposal, and you can, customize each of these steps, now it becomes much easier to build a data system. This could be a database, for example. You add a catalog, it becomes something like DuckDB, right? Or if you distribute it, right, then it becomes something like Spark. It's a data processing engine. Or maybe you want to embed this SQL capability to some other application. Okay, now then it becomes a client query engine. So whatever data system that you want to build, now the barrier to building this data system is going to be much lower, right?
Yeah, by the way, so this is the scope for the ArrowDataFusion, right? And
yes, this is DataFusion scope.
Yeah, so I don't know too much about that space, but roughly I know Arrow might be. My impression is more about this representation for encoder, decoder data or marshal data in the memory, in the network, so it'll be very efficient. And maybe the other
Yes.
ArrowFlight, and how those like ArrowFlight, ArrowDataFusion, those technology under the same name. What's their relationship?
Yes, Arrow is the parent project, right? Because everything starts with actually how you represent the data. Like what is the data layout in memory? Like how do you serialize data? Do you pay any costs in serializing, or is it very cheap? Like how do you actually facilitate data interchange? Like if you have a distributed system and data has to go over the network, how do you facilitate this? So Arrow gives you a standard for representing your data so that you can do things very efficiently with it. Maybe this is like scanning your data, serializing your data, sharing your data. Once you have that, you can start building higher level technologies on top of it, right? The data fusion is one of those higher level technologies. Flight is another such technology. Flight is for like how do you represent SQL and things like that. We have mostly worked on the data fusion side of things. I think one of the people that you can talk to if you're interested in like the representation bits and bytes of the Arrow stuff. Andrew Lamb is again a good person, but there is also a collaborator of him, Raphael Davies, also from InfluxDB. And Raphael is the maintainer of ArrowRS, the Rust implementation of Arrow. And I think he can give you a lot of high quality information about like how is the Arrow specification implemented in Rust, and how efficient it is compared to the old way of doing things. So that's another pointer I can give to you. And one technology that's in the same ecosystem is Parquet, the file, right? Yeah. So once you have Parquet, the Arrow representation, Flight SQL, and Data Fusion, you already have like a lot of the fundamental technologies to build whatever data system you're building, right? There are a few things missing, obviously, like catalog, for example. You need to design your own catalog. We haven't, as a community, we haven't gotten around to building that. And I'm not sure even if it is within the scope of this community, probably not. But there are certain other components that you still have to think about. But this whole Arrow, Parquet, and then Data Fusion toolkit really, really makes it easier compared to how it was before to build a data system.
Cool. Yeah, I think last year I attended, early this year, the Data Council in Austin. I think I joined some of the cool talk about Arrow. And
yeah, I attended the Data Council in Austin too. It was great. I love that conference.
Yeah, there's a cool idea about the ADBC, right? The Arrow data connection activity. Even there's some idea to, even at the low level, there's a CPU and GPU and the memory stuff. They can using Arrow to make more efficient. That will be really make everyone life easier and save cost, right?
Yeah. You also work on a database. So this Arrow technology is, I think it's very promising for databases. As far as I know, InfluxDB, for example, did a complete rewrite at version 3 of their database to leverage Arrow, Parquet, and Data Fusion. So there are some players who really believe in this. It's not just us. It's actually Influx was in this before us. We came in fast and we're working hard, but they have been working on this for a long time. I think there are some players who are really adopting this technology as quickly as possible. And I think it will be good for the community, for the whole data community, even if it's just the Arrow file format that everybody agrees on, Arrow representation and Parquet file format. I think it's still a huge win. It's still a huge win. If everybody speaks the same language in terms of formats.
Yeah, I think your company even maybe top 3 of the contributor for the Data Fusion project. Is that right?
Yes. So blame-wise, Git blame is not a good measure of things. But the other day I was curious and I took a look at it. I think we're at 12%, 13% or something like that. And if you measure if you look at the positive delta, how much additions minus subtractions, we're almost the biggest contributor. It's also again a very bad measure, but I think the moral of the story is we are working hard on Data Fusion along with other members.
Yeah, that sounds great. And even I listened to the other tech talk 1 or 2 weeks ago, and someone mentioned that they choose to use ArrowFlight as the SQL interface, and also leveraging the GDBC and the ODBC driver from Flight, so it makes things easier. But according to them, that is they because their code base is also C++ like us, and but he mentioned that if they can start a new project right now, most likely they will choose DataFusion and also Rust. As you mentioned, they give very good building blocks for you to focus on your own language, not reinvent a view, build everything low level by yourself, right?
Yeah. I think it will help a lot of people when they're building data systems. And it actually already has a lot of very cool tricks that some of which we put in DataFusion, some of which other people, other members of the community. Like it's very good, for example, at making streamable plans. Like it looks at how your data is ordered, and like it makes very, very clever optimizations to avoid anything that breaks the pipeline as you're evaluating a query, right? And that's one of the fundamental problems that we need to solve to really unify batch and streaming. Like if you want the same query basically to be able to run both on batch and streaming data, your query plans should never break the pipeline. Because if you have a query plan that needs to see the entire data, then it can never stream, right? Because you will always wait to consume the entire data. The data never ends, so your query will not run. But if you're smart enough to say, hey, look, my data is ordered according to whatever sequence number, timestamp, and this query is actually runnable if I know this and optimize according to this very well. I never need to see the entire data. I never need to resort. I can always make use of these already present orderings. Then suddenly the query becomes streamable, and you can use the same SQL without any special syntax or special constructs or functions. Just standard PostgreSQL SQL, and it will run on infinite streaming data. So this is one of the advantages of DataFusion, and we have invested heavily into this because we are a stream-first AI native data infrastructure company.
Nice. And I think in the Java world, Apache Flink and many other systems, they're using a project. I forgot, is that called Apache Casadel, right? Is that some similar feature covered by DataFusion that is parsing the you build the AST and push down operator? Okay.
Yes. Yeah. Actually, these are the projects that I think historically gave way to DataFusion. Like if projects like Calcite didn't exist, for example, right? I think DataFusion couldn't exist. Because after Calcite, a lot of people realized, look, if we have actually this thing that is able to give me the AST and stuff, it's very useful, right? And then as a next step in that idea, people started to think, what about logical plans? What about optimizations to logical plans? What about physical plans, physical operators? What about optimizations in physical plans? So none of the ideas is actually new. All of these things are known and they have existed as separate technologies that people would be integrating, or if they don't want to do it, they would just go and use something like Spark. What DataFusion says is, look, I have all of these steps inside of me, and you can use which ones that you want, and you will not need to integrate Calcite with this, with that. Your life will be easier. But it's the same logic, it's the same ideas. It's just under one roof, and it tightly integrates with Arrow.
Okay, cool. And DataFusion also cover some of the common functions, or that depends on the underlying system. The SQL functions, right? Those are common stuff like min max or P90.
Yeah. It comes out of the box. Yeah.
Okay, and you can easily extend for your own.
Yes. You can define user-defined aggregation functions, user-defined window functions. All of those you can extend.
Yeah, cool. And I think
that's the whole point, right? Extensibility.
I
give you the basics, and you can build whatever you want on it.
Nice. I even saw some lines on their documentation that is, it is intentionally designed in this way that is DataFusion don't cover storage or catalog, right? That's your
Exactly. It's intentionally designed this way. Yes. We are actually, I think you will be, maybe the viewers will also be interested in reading a paper that we are writing as a community, the DataFusion community. Let's see. So we are going to submit it to a few like data conferences, the usual ones. It's an academic paper that discusses so our thesis is you do not need to have a very tightly integrated database or data system to get high level performance. You can actually have all of these components that I mentioned separated as modules, and they are all extensible, and you can mix and match which ones you want to use. And if you build this system out of these components, it will still have a comparable performance with a tightly integrated system. So that's gonna be the main thesis of our paper, and we're gonna like run these, classic TPC like queries with a DataFusion system, and we're gonna run it with like a tightly integrated classic database, right? Like DuckDB or whatever database that you can think about, and we're gonna compare like, look, the performances are not that different, but DataFusion is actually super extensible. Like you can turn it into whatever database you want. It is just a foundation which you can customize, and you don't need to sacrifice performance for this. That's our thesis.
Oh, interesting. Is that, I'm not sure I read this correct, that it's more like kind of microservice for database, but not have to be...
Yeah, I think it's a good analogy, yeah. Before we had monolithic backends, right? And we were thinking, okay, this is how you should build software because one, it's high performance, and two, it's easier to build systems this way. And then like 20 years ago, this whole microservice thing came out and it said, look, you don't need to do everything at the same time. Just think about these like services separately, and then they can cooperate with each other to, comprise your application. So we're trying to do the same thing for like data systems. So I think it's a good high level analogy. I like it.
Yeah, but are they still in a single process, just to have a different component share data to each other, or even you can break into different process using network to communicate?
You can think about it this way. All of these fundamental things are a separate Rust crate. Crate is like a library that you import, right? So you can import the entire DataFusion crate, which imports all of these things, and then it's a ready-to-go query engine, right? But you can just import the, SQL parsing and logical plan part. Maybe you just use those and you have your super proprietary secret physical, execution engine, and then you use that. So that's the beauty of it. So this is not like microservices in the sense that they run on different hosts. But this is kind of like microservices in the sense that you can only choose the libraries or crates in Rust jargon that you want, and then compose it with your own stuff.
Okay. Yeah. If I think the other energy is more like you don't have to go to grocery store to pick up this ingredient, the other ingredient. Something is made almost ready for you, and you can cherry pick and quickly build your own
yes.
thing, right?
Exactly. Yes.
Yeah, that sounds really amazing. Then, is that still left to the DataFusion developer to handle stuff like distribution or failover cluster or even concurrent?
Yeah. So concurrency is built in. Concurrency on a single host is built in, right? So it tries to make best use of your cores, however many you have them. But you are right in the sense that it doesn't do like fault tolerance and recovery, and it doesn't do distribution. So for those, there is a project called Ballista. Ballista uses DataFusion and adds these features to end up with something like Spark, basically,
Okay.
right? So that's again a use case of DataFusion. It's under Arrow. It's Arrow
Okay.
Ballista.
Oh, nice.
Yeah.
But this is even higher level, right? So
It's
give
yes,
give some predefined stuff, but you might lose certain.
yes,
Okay. Okay.
yes. You remember the whole idea is to deconstruct it so that you can do like this mix and match.
Okay. Yeah. Yeah. Again, I really think this is such a great effort together, right? Is we don't really keep building low level stuff. There's some framework or some module. Even you can cherry pick which one you really want in when you design a new database or new system. Yeah, this is
Yes.
something that's brand new idea, but I'm so glad with this community, with the Rust and other folks or vendor in this space, since it's so promising. I do see many new databases coming, especially from the Rust world. They are like data fusion can be the default like fundamental stuff they have to considering, and they can add their own kind of a concept and philosophy into it.
Yeah, I think so. I think that would be a fantastic future. Like if it really takes hold, and if people start building like a lot of data systems with data fusion, we would be very happy to see this. Yeah, and I'm really hopeful. Like people who watch our like this episode, just go and check out data fusion. I think it is very promising. It's being used in like very different places, by the way, like not just databases or like engines or stuff like that. As far as I know, there's even a use case in a visualization application. I can't recall, but I think it's in the list of known users.
Wow. Yeah, it is really eye-opening or mind-blowing. Yeah, I will check with you and put some link down below in the video description.
Okay.
And yeah, feel free to just go to the arrow.apache.org. I think that's the umbrella, and you can find the many stuff. And also try to link some cool paper or projects. So if you want to learn more, and yeah, this is really something very promising again. And I'm so glad to hear you all those kind of visionary stuff regarding AI native database or like unified stream and batch processing. We at Timeplus also working on that same direction, also have our core engine open source. I think this is really deserve a very big effort together to challenge each other, to help each other, and to really to change the mindset that is, yeah, processing data it should not be so expensive or like have a different
Yes.
stack. You can unify everything and choose a good project to see more value from your data or power.
Definitely, I definitely agree with you. There's a lot of smart people who are thinking about solving this problem, and there are different approaches. Ultimately, I don't know what is the best technical approach. Only time will tell, right? But I am very glad to see a lot of these folks trying to solve the problem with different approaches. If one of us succeed and we actually end up with this like unified batch and streaming that easily integrates with AI, so AI native in that sense, it's a huge win for all the data practitioners. Like all the data engineers, ML engineers, they can create many more applications. They can interact with their databases much more efficiently. And even non-engineers like analysts, then they can also efficiently create stuff with this, right? Today, using these data technologies are unnecessarily hard. But at the end of the day, what people are doing, what people want to do is not that hard. They basically want to be able to say, look, I have this data coming in and I want to match this data with this other data and maybe feed it to some large language model, whatever they're doing, right? Like they can describe it in a few sentences. If they can describe these things with a few sentences, we should be able to provide them with a system that actually takes those few sentences and then runs it in some like professional cluster. It shouldn't be this hard. I think it's only this hard because of historical reasons, as I said. Like we have been like developing this technology piece by piece, and as a community, as we have been developing this technology, we weren't seeing the full path ahead of us. So we were only solving the problems like right in front of us. But sometimes as you keep doing that, you end up at the wrong place in terms of complexity and things like that. So I think it's a very good time these years, 2024, maybe 2025 as well, to really take a shot at solving this data tooling complexity problem. If this problem is solved, then a lot of new data and AI applications will, be built by a much larger group of people, not just like very expensive data engineers or like AI engineers. Then a lot of other people will be able to say, hey, look, it's just this easy, it's just standard SQL. I can actually just write my logic in this and then deploy it and then it will run. So I'm excited. And I think DataFusion is one of the potential candidates that can solve this problem.
Yeah. Really promising. That is, the AI now it become something you cannot avoid, and the next step of AI is become a data problem, right? So how to more efficiently consume data. Maybe you're just using like English or your natural language as your SDK, but you cannot really spin off like tens or twenties of different microservices as a Lambda architecture to build stuff. There's so many factors. If we can build a very solid like streaming SQL or unified SQL for both streaming and the batch, then that kind of NLP or language English to just convert to that SQL, and that SQL can handle all those low-level stuff. Yeah,
I definitely agree. I think the SQL is here to stay. A lot of people think, oh, look, with LLMs, the programming language or the data language is now plain English. I don't agree with this. I think SQL will be like, how when C came out, did assembly die? No, the compiler actually turned C into assembly, right? So a lot of people will just express their queries in plain English. I agree with that. But AI will not directly talk to the database. It will just convert it to SQL. So if we have a unified batch and streaming standard SQL, then we actually crack this problem, because AI is very good at converting English to SQL. That's the easy side today. Previously, it was hard. Now it's a solved problem.
Yeah. And now that AI say, I'm ready, but you are not ready. Yeah, move faster with the DataFusion.
Exactly. And I don't know, what do you think? It's surprising to me. I would always think like doing something like that should be harder than, doing the SQL, but apparently not.
Yeah, so today SQL is still relatively easy and accurate way to describe what you want to analyze, right? But I won't be surprised that the language model will be better, but again, we need a even stronger, be more expressive.
I agree, definitely. So I have a question for you. Talking about Rust and how Rust is becoming more prevalent in the data ecosystem. In Timeplus, when you first started, did you consider Rust, or at the time Rust wasn't that developed?
No, I think we had a discussion regarding whether we should start from Rust or move to Rust, because our company is almost 2 years old, right? And Rust was invented, I don't know, maybe 3 or 5 years ago. And even when I was in the previous company, Splunk, there's a lot of discussion whether certain components need to be written in Rust. So definitely there's an option over there. But the other thing that is we do think there's a lot of stuff we can leverage, for example, from ClayHouse, right? So there are maybe 500 or 1,000 different functions very solid, like the codec or those low-level stuff, and we can really take that as a good foundation and focus more on the streaming processing side. But at least at that time, there's no really super mature Rust-based OLAP. So and also we already familiar with C++, and so that's the reason. But again, with our architecture, it should be easier to build a new component in Rust, especially for our cloud offering. Right? So we can have a certain component in Rust, certain component in C++, or we can do kind of compiling tricks to embed to each other. And even I see more and more projects, they having the Python as the interface, the API, but underlying kind of a core engine is actually a Rust code. So it's a good balance about this usability.
The Python Rust duo, I have seen it used quite a few times, and I think it's a good idea. Do you know this data frame library called Polars?
Polars, yes, for sure, yeah. And they have a Rust version, right?
Yes. Yeah, so their entire thing is written in Rust. It's just you can use it from Python, so it gives you bindings, Python bindings, but the actual library is written in Rust. So this is a pattern that we're seeing quite often, and I think it actually makes a lot of sense. DataFusion, by the way, does the same thing too. Like, remember you asked me like, can I define my own functions, right? You can do it in Python if you like. So it gives you that Python binding facility. So you can define your own functions in Python. Obviously, like if you're super performance sensitive, it will not be great, right? Because your logic will run in Python. But if it is not performance sensitive and you just want to have the convenience of writing your own aggregations or whatever function in Python, you can write it in Python and you can use it in any DataFusion system because it integrates with DataFusion. That's again thanks to Arrow.
Is that possible to leverage like WebAssembly together with DataFusion as a kind of a sandbox?
Yes. Almost WebAssembly actually WASM, I don't know how to pronounce it. I think it's WASM, right? WASM is a compilation target for DataFusion. So you can actually run it in browser, right? I mean, I haven't tried, but it compiles, so one should be able to run it. But I think that I don't know if this is too technical, but well, this is a technical podcast. One of the challenges with doing that is the threading support in WebAssembly. It doesn't conform to full POSIX, as far as I know. You have to go integrate some other like VASIX. I'm not sure. Like you need to do some other stuff to get full threading support. So when you have a query engine, you want the engine to partition the data into as many cores as possible, right? And if you run it on WASM, it doesn't do it today because it cannot spawn more than one thread. But my expectation is this will be solved at some point.
Yeah. It doesn't sound to be very
once it is solved. Yes.
And on the flip side, is that okay to have this DataFusion as a Rust process to have a component of WebAssembling and running your UDF in Python, but it's compiled to WebAssembly in that WebAssembly sandbox, but the overall parent process is still DataFusion?
Not sure. I don't wanna say something that could be wrong. Yes, but I understand why you want to learn this. Yeah, I think it would be cool if it supported that. Yeah.
I noticed that is you have the PhD in your title, right? So you are being very accurate, but also have a good mix of entrepreneur, which is very nice.
Thank you. All right. Is there anything in particular about DataFusion that you think people would want to know?
Maybe the last question is more about like if you recommend any conference that is I'm sure whether they are solely focusing on Arrow DataFusion or this a good coverage. Then some of our audience can try to join those conference or some meetups.
Yeah, I'm actually glad you asked this. So a few touch points. So now recently we are, as the DataFusion community, much more active on Discord. So Arrow has always been active on Discord, but now like we have a separate DataFusion channel, and we hang out there. And if people are interested in DataFusion there, please come to the Discord and the channel, and we'll try to help you. This is the virtual channel. As I said, if this paper that we are preparing, it will be presented at whatever conference that it's gonna get into. I don't know which one yet, but we will announce it in the channel. But what's even more interesting is we were just discussing as the community to organize a DataFusion event, probably Q1 2024, somewhere in the US, I think.
Yeah.
And I would be very happy to meet all of the DataFusion users in person. If something weird doesn't happen, I'm gonna be there. Andrew Lamb is gonna be there. Hopefully the project creator Andy Grove will come too. I don't know if he will, but I would love to see him there in person. But at least I can say like a lot of the people who are recently active on the project, I think we'll be there, and we'll discuss how we are using DataFusion in our projects, the roadmap for DataFusion. I would be very happy to see all the builders, be it startup founders, engineers at big companies who want to use DataFusion in this event, and we will do our best to make it a worthwhile event. But again, we are still thinking about setting it up, so no firm date or anything like that yet.
Okay, cool. And also, thank you for sharing that Discord. I guess most likely this video the link will be shared to that Discord channel. And
yes.
And I'm not sure whether you guys figure out a good name or fancy name for this kind of summit. But again, people will be
we're open to suggestions. We don't have a name yet.
And the people really see this as the future. They will talk to their boss to reserve certain travel budget. This is really a good way to connect better with the community members and build something bigger.
Exactly. Talking about names, the only thing I don't like about DataFusion is maybe the name. You know why? The name itself is okay. I mean, DataFusion, you bring together data. Okay. But it's an old name. There's a lot of other Google has a product called DataFusion, right?
Oh, really?
And then it's totally it does something else. It has nothing to do with this kind of thing. But it is hard. When you say just DataFusion, some people who don't know ArrowDataFusion, they think about the other DataFusions. That's the only thing that I don't really like. But I'm used to it, so it's okay.
Yeah, I mean, name is always challenge, and there's a cost. If you move to a new name, you lose all those, not just SEO.
Yeah, we're not. I don't think we're gonna. This is not. It's my personal opinion. I don't think this is a discussion in the community. It's just that when I type DataFusion to Google, I would prefer to see at the top ArrowDataFusion and not Google's
But I mean, don't
totally
worry.
different DataFusion.
This is something can be fixed, right? I mean, when community is getting bigger, and there's a lot of blog and stuff on that one, the search engine will be smart enough. Hey,
I agree. I mean, this is just I think a funny, weird way to end our conversation. Of course, name doesn't really matter.
And maybe hopefully someone in Google watching this and they say, oh, maybe I will
Yeah.
contribute this name back to community. I'm not using that name again, so it will be nice.
Yeah, right. I mean, Google is known to kill products all the time, so maybe they will kill their own data fusion, and then we'll be like, okay, we have this name for ourselves. That will be funny.
Yeah, okay. Yeah, it's a very good ending to close this episode in a casual way. Yeah, again, I'm so glad and to talk to you and learn so much. And compared to what I know last week, I know much more, and really needed to check more details. And I will share some links and books, maybe a blog in this description. And if I can join that the conference next year, that'd be great to see you in person and many other folks in that space.
Yes, yes, I would be very happy to see you too. Well, Joey, thank you very much for inviting me. It was a pleasure to talk to you. I think hopefully more people will know about our community and our project thanks to you. And hopefully people have an easier time in building their own data systems with our help. So thanks for having me. I'm glad to have come and chatted with you.
Yeah, no problem. And thank you, Ozan, to share this your story and your expertise on this with us.
Yes.
And, enjoy more coffee and see you next time.
Streaming caffeine. Yeah.